Hello, my name's Dominic Quiche. I am the Head of Product Management for Sensive. If you haven't come across Sensive before, Sensive are a supplier, an integrator of wireless condition monitoring systems. We work with many different types of infrastructure, construction, rail, mining, supplying them with instrumentation, wireless communication to suit their needs. The talk today is I'm aiming to highlight the need to consider the full data flow and all the key components that go into getting your information from A to B. So I'll start with a sort of a brief overview of remote condition monitoring for those who aren't familiar, mainly around where Sensive integrate and impact this industry and why it exists. Also, when stipulating or designing your monitoring system, where the key considerations need to be, where you need to evaluate in order to get the output that you set out at the beginning. Challenges, there's always lots of challenges. Look at things that are usually plausible on paper, but in reality don't necessarily come out that way. And then I'll try and look to summarize that all into and bring it back round into mapping out the journey, and less so about the parts that make that up. So remote condition monitoring, the term can be applied to lots of different applications and industries. And in this talk, and specifically for Sensive, we're focused on asset management within the infrastructure industry. It's an application within this area through installing of field equipment in the shape of sensors or observation apparatus that can provide information about an asset's behavior. And generally, the way that we've been doing this and move forward is to do this remotely. Remote monitoring has grown, has developed through a number of different reasons. An aging infrastructure, so the need has increased over time. Technological advancements, so the availability of different methods and different types of uses has mean that we can move forward what we do with remote monitoring. Better governance, better practice in the ways that we protect some of our assets and we manage them going forward. So why would you monitor? Why would you monitor? Why would you go one step further and turn that monitoring into be automatic or remote? And there's a growing list of reasons. I've pulled up a few here. Information, trying to discern how an asset behaves, e.g. the effect of different vehicles on a bridge, how that loading might affect that bridge. You might want to put some monitoring on there to understand what's happening in that stage. Compliance, something we saw quite a major boom in the last 10 to 20 years, where we're protecting assets from new developments. A great example is the Crossrail project, where we put a lot of monitoring on different assets throughout London. So when the tunnelling took place, we understood how those assets were behaving, whether they were being affected by the tunnelling work specifically. Risk management, especially big within the railway, where you can't just stop services, you can't just fix faults if you see one occur. So you might monitor in the short, medium, or even long term. Safety, which is along the sort of same lines of risk management. But if there's a direct chance of increasing the level of safety, then monitoring should be deployed. And sustainability is sort of, one of the buzzwords I appreciate, but increasing the life cycle of an asset by applying monitoring techniques to different types of assets, you can increase the level of maintenance, you can fix faults before they become major impacts, and you can keep assets going beyond their design life. There are lots of different ways of capturing the information you need, and understandably a lot of the focus is on the field equipment which is deployed, and it depends on your definition, but generally The two different types of methods used are using optical or geospatial or a sensor-based system. Although it could be argued that some of these are all of them are sensors, in fact. And then within the sensor category, you can have wired or wireless. And despite working for a wireless company, there is certainly a place for wired systems. However, where they used to be the standard and the only way to go forward, they've now become a minority, and we use wired systems specifically for certain applications rather than just how we roll out monitoring. This is a very, very, very sort of simplified look at how the flow of the system might work. There's lots of considerations along the way and lots of moving parts that need to be considered. But essentially, you've got sensors. They're things that are collecting the data, the necessary information. A few examples up there: tilt meters, crack meters, automatic total stations. Typically, where the industry focuses is on the sensors. That's where innovation is focused. New ways and accurate ways of capturing the information from an asset. And at the other end, you have display. This is what 99% of clients see at the end of the day. They don't necessarily see the field equipment. They don't see what goes in between. They just see the platform at the end, and they see how it's displayed and how it's set out. And it's this part in the middle that is often sort of neglected, really. It's not particularly sexy. It's not a shiny new sensor. It's not a really cool way of showing something. And I'm not suggesting it's more important than the sensors or the display, but it needs to be considered in the same bracket. You can't specify, I need this sensor and I want to show it this way without thinking about how that information gets from A to B. And this is Senseive's data flow. And hopefully you can see there's a lot of steps from how we get from A to B. So where we have the sensors on the left-hand side, communication, the wireless communication or wired, whichever route you want to go down, how you get it back to the controller. Communication from the site to your database. Are you using cellular? Are you using Ethernet? Are you using SATCOMs? Are these even available? What's the impact on that outcome if you use cellular or SATCOMs? Does that slow things down? Is that a key requirement for your deployment? Data management, sitting in the middle. How is the system controlled? It's got to be controlled remotely. Is that remotely from a site office, or is it remotely from a cloud-based system? And how is the connection time managed? Is there any autonomy? You know, when we look at how, in particular, wireless systems work, we purposely manage the time and the upload of the gateway to ensure that it can live off a very minimal battery life, which means you can go and deploy it in a very awkward, remote area very quickly and very easily. So making sure that your data management process in that middle part is in line with what you're doing is fundamental. And then, the display at the end, there's lots of options here. Do you want to go to multiple data visualization platforms? Do you want it to go to one? Do you want to pull that information off and manually start playing with it into a spreadsheet? All of these steps have to be considered. Because this is what most people see, especially the end users, when they're evaluating their remote monitoring system. Again, I'm not disagreeing with the importance of the data visualization. It is extremely important, but the entire flow needs to be considered. For example, if the client is expecting to see 24/7 remote data of a railway track in, let's say, the Australian outback, then setting up a system to capture the information from that railway, pretty simple. Displaying that information on a platform, pretty simple. Getting the data from the Australian outback to that data visualization, not that simple. We need to pay enough attention to how that flow goes through that to ensure that we're meeting the requirement at the end. So other key considerations when you're selecting system, the output, a sensor or an optical system will capture information in a language or in an output that it's designed to do and what's natural for it to do. It won't necessarily be a technical or an engineering value. And this therefore needs to have some level of processing or calibration. Sensors, and when I use the word sensor, they're almost entirely relative. And therefore what application you're using for them needs to be considered. And a good example is when we look at, say, track monitoring. You might use a tilt meter to measure CAN, cross-level change. In the railway, you use cross-level to turn trains, so it's a relative movement. You're not that fussed about it reaching a maximum. You just want to know whether it's changed from zero. You add two cross levels together and you get a twist of the track. Now, the twist of the track has a limitation. You can't exceed that. It doesn't matter what you're at. You can't go past, let's say, 50 millimeters. So if you're at 49 millimeters, it's not a relative movement. Your baseline is 49 millimeters. You might have 1 millimeter to play with. So you need to be considerate of that when you're selecting your monitoring system. And in that particular case, you'd have to back it up with a manual system to set as your baseline. You say, right, I've done my manual suite. That's where I'm going to set my baseline at, and I can use that from a degree of change from that point. Practicalities, again, very much a forgotten part when we're looking at field equipment. How do we fix it? What impact will that have to the reading? If we're having to fix it with magnets, we're having to fix it with glue, whether we get to drill and fix. How do we communicate with it? Are we using wireless? Are we using wired? And then how do we power it? Is there mains power? Have we got solar panel? And logistics, the dreaded C word, cost. Is it a long-term deployment? Can it be reused after? How large is the length of area that we're looking at? Some systems look extremely good on paper, but when we get them down into a site, construction, rail, highway, the logistics of getting it in actually outweighs the value of the monitoring in the first place. Environment has a huge impact. It's often understated, it's poorly understood, and its effect on, say, a monitoring system, is really important, and then its subsequent effect on the data flow. This is a good example. It's a site in Kent, which was perfectly normal by all accounts when we looked at it on a map. But this little 200 meters of track is where the cellular signal went to die. There is nothing, for no reason that we understand. It is a black hole of cellular signal. We had some slope monitoring system in there, we had a camera system, and it just couldn't get its data out. So we actually had to bring somebody in to with a special antenna who could actually point to the smallest angle to pick up 1 bar of signal so we could get the data out. And we had to move the camera antenna right to the top of the cutting because it had a bigger packet size. Again, if we knew these and we took those considerations into account at the beginning, we might have looked at a different system that was more suitable. Cameras, often an integral part of a remote monitoring system, by virtue of it being remote, and I'm using the word remote there in a hard-to-reach place connotation. An engineer, a surveyor, when they see a piece of movement on a sensor, their automatic reaction is, I need to see it. I need to see what's going on. So we install a lot of cameras, and that acts as a visual check. We don't install them for photogrammetry. It's where they see movement on a piece of kit, and they can validate whether the movement has impacted track or impacted a highway, and they need to shut the road, shut the highway rail, or they need to put slows on. There's lots of impacts to your imagery, and it's not just on the logistical side. As you can see, different weather conditions, whether you've got a light source in the area, whether you're pointing up and down the hill, or all these sort of factors need to be considered when you're looking at how that image is captured. And again, with imagery, if you naturally our cameras use long exposure times to take their image at night. If you've got lots of ambient light, it can take that image very quickly and send it back. If you haven't, spend a lot of energy, sends a lot of power to try and generate that image. So suddenly you've got to think about that, whether you need to get mains power to your site or whether you need a bigger solar panel. one of the main points of this talk was to highlight the need to consider the whole journey and not just the endpoints. And that doesn't mean you just focus on the A to B section, but put it in the same bracket, as I said. And when we look at a system and the outcome needed, part will be around latency. It's a very popular word in the I&M industry. So we need to ensure that the architecture of the system that we're using meets the specifications set out, meets the requirement, and meets the purpose of why we're monitoring. And often you'll need flexibility within that to adapt the project as the project develops, or, as I say, as environmental impacts or unforeseen site conditions change how we might have to move and how we operate the system. I'm probably labouring the point slightly, but what we sit and plan in our nice warm offices or home offices isn't always what we experience on site. Site walkouts and visits, they don't solve things straight away. They still don't capture all of the different variables, but they do alleviate some of the surprises that we may experience. And we need to keep in mind the clarity, the purpose of the monitoring. So at the start, where we talked about why we're monitoring, whether it's compliance, whether it's information, whether it's risk management, we need to keep that at the back of our minds in case we need to sacrifice a small part to ensure that we meet the original purpose. Real-time monitoring. This term is thrown around fairly sort of willy-nilly in the monitoring industry, and most of it is misused, if I'm perfectly honest. And effectively, it's when a movement happens to be able to review that data, so a decision could be made in real time. It's a very generic term, and as I said, it's largely misused. And this is an image, and I was trying to explain this. This is an image of one of our clients who measures ring deformation after a TBM passes. The data is sent in under a second to a dashboard that sits on the TBM to highlight to the controller whether there is a change in deformation of the 11 rings behind the TBM as it moves through, and there is a person sitting there looking at the screen. That is about as close to real time as you can probably get. And even then, it's probably still a second or two behind. And my point being with this is, unless you have somebody looking at that screen, actioning whatever they see, is there a need for real-time monitoring? Because otherwise, it's just building up information. And so therefore, when you look at your data flow, do you need the data to be sent straight away, or can it be sent in batches? If it's for reviewing afterwards to understand how the tunnel in this aspect is behaving, you don't need to see the data at one given point. You need to have a look at it when you're ready, and make sure you're collecting it at a high frequency, which is a totally different thing. So when you hear people say things like real time, just have a little bit of a question as to whether it really is what they mean it to be. You might also hear a lot of people say things like near real time, which is describing the ability to alert an asset owner or an engineer as close as possible that an event has happened. A good example of this is when we do slope monitoring. Our system reads statically, whatever sort of specification we set it at, half an hour, 15 minutes, and we will, and if it picks up a sudden change, it will escalate that alert and send it back to you as quickly as possible. That's only as good as the cellular connection or the SATCOMs or whatever sort of network that we're using. So invariably it's 1 to 2 minutes. So again, it's why understanding your purpose at the outset is absolutely vital to set up the flow and make sure that it's correct. Another key element for obtaining the right tools is obviously your data management tool, and this will get this is basically does all your heavy lifting. It's also your configuration, any commands, keeps your logs of action, sends your data to different parts. And Sensive.io is our new platform that we're bringing out, which allows the user to have complete control over their system and move it to where they need it to go. System health monitoring. Data is only as good as if the data is actually getting there. If you're seeing sensors with low battery, with poor signal strength, or dropping from their cellular network or from their internal wireless network, it's better to be forewarned so you can do something about it. Often in some circles, if there's no data, they consider that a failure, and so they will stop a train, shut a tunnel, stop works because there's no data. Having your context will allow you to sort of alleviate things that naturally happen when you're on site. Another key element when deploying the system is defining where your data flow sits. Some projects and do not allow data to leave that site, so they need it to stay wherever they are, and therefore they can't have the data go use cellular connection or SATCOMs to come out. In this case, Sensei.io, we've developed it to be installed onto someone's laptop, onto their local server, so they can do that. Finally, despite all the planning, another sort of key message is around the ability to make your system flexible. This rings true from field equipment, on the bottom right, having to adapt some of the sensors on site to shield them from any falling debris, to adapting our front-end platform to allow different types of calculations to look at rate of change. And this will in turn allow flexibility in what, some of the things that we see on site, the environmental impacts and the unforeseen things that we see in the planning. So in summary, and going back to this sort of image of the flow, understanding that data flow and focusing on this and the data is key to a successful deployment. Not just the bookends of sensor and visualization, although vital, you need to understand what happens in between. This will impact the type of system you can use, the way that you deploy it, whether you need to use a local or a cloud-based system, and what data management tool will really suit you. And it will assist with overcoming sort of site challenges with latency and comms. For example, if you're putting a system to act as a warning system for critical infrastructure, latency is the most important aspect. Data that needs a lot of processing, therefore, is probably not ideal. Data that uses a large data packet, not ideal. Therefore, an assessment of these sort of parameters at the outset will allow you to design accordingly. Ultimately, paying proper focus to the data flow and the environment, bringing it back to that purpose, why we're monitoring in the first place, will help you define the type of sort of remote monitoring system that you need. Thank you very much.